All right, so welcome to another episode. We are looking at oxidation and reduction, and we want to big a shout out to Elite Detailing, Evergraphics, Photo Studio, and D&J Document Center. They are proud sponsors of Buckle Down Tutoring Services. And so, as we continue to get you prepared for your 2025 or whichever year you'll be in for your chemistry CSEC exam, we want to let you know that you can watch these videos and utilize the information, making yourself more rounded so that you can answer questions when you get your paper two or your paper one. Again, I am Mr. Thomas and I'm the founder of Buckle Down Tutoring Services. I hope this video will provide you with some vital information on the topic. Remember to like, share, and subscribe, and leave a comment based on the topic that you wish for us to go in detail. And we're going to jump right into it. When you think about oxidation and reduction in chemistry, short, you often see them abbreviated redox reaction. And so for a redox reaction, both oxidation and reduction are happening simultaneously. And in the past, scientists would have linked this sort of reaction to oxygen. So they mainly focus on the concept of oxygen, whether it is being lost or gained in a compound. So as I said before, the redox reaction technically is shortening for oxidation and reduction. Now, one of the things scientists used to do in the past is to link this sort of reaction and zeroing in on oxygen. So they usually speak to mainly oxygen. And this is what they say. So they would say reduction is the loss of oxygen. So normally, typically, they say when a compound loses oxygen, then it is being reduced. Um, Oxidation is the gain of oxygen. So typically, they would have made a link that once a compound is gaining oxygen, then it is being oxidized. Once a compound is losing oxygen, then it is being reduced. But over the years, scientists recognize that it is a lot more than that. And so now, when we're dealing with oxidation and reduction, we speak to two other things. Yes, oxygen is very important, but the scientists recognize that what happens is not all reactions may have in oxygen. And even if the reaction does not have in oxygen, you still have the possibility of a redox reaction. So they are saying to themselves, so how we having the redox reaction if we're limiting it to the loss of oxygen and the gain of oxygen if there's no oxygen there in the compounds? So they started to targeting electrons and oxidation number. So I'm just going to now input what they say about oxidation and reduction in terms of electrons. Now we know electrons are found in the shell of the or energy level of the atom. So reduction is the gain of electrons. And so for compound,
Excuse me.
yes,
Are you typing? Are you presenting? I'm not seeing if you're doing so.
one sec. So the gain of electrons is reduction. And this is not something that sits well with students because how can you be gaining something yet still you're reducing? And so you have to look at it as going back to subatomic particles where we look at the electrons and the charge. So an electron is negatively charged. So the compound will be gaining something that is negative, and hence that's why it is being reduced. So the gain of electrons is actually reduction. Now, the other link that you can make is between metals and nonmetals. You should be thinking to yourself, what happens with a nonmetal? Nonmetals typically are electron loving. And so, if you can recall, when you look at the periodic table summarizes the concept of while you move from the left to the right, you're getting more electronegative. So from the left, you have the metals. Moving to the right, you have the non-metals. As you move towards the right side, we're getting to become more electronegative. And so we know that those elements like to gain electron. And so, as a student, you can put this in your back of your head. You know that nonmetals typically will undergo reduction because nonmetals are the ones that gain electron. Now, the other way in which we look at reduction or oxidation is the oxidation number. And under reduction, the oxidation number increases. So under reduction, these are the three things that you can focus on. So if something is being reduced, and as I said earlier, not all the time you can use this concept about oxygen because not every compound will have or not every reaction will possess oxygen in it. But it's something that you can use. Reduction is the loss of oxygen. So when you look at an equation where oxygen is being lost from a compound, then you know that it is being reduced. The next way we can look at, and we said that scientists now ventured into these two in the latter part. And so we know while we are studying the chemistry at the CSEC level, you should know that reduction is the gain of electrons. And reduction is a decrease in oxidation state, right? And we're going to talk a little bit about oxidation state right after we deal with the concept of oxidation. So these are the three things that we will categorize in terms of reduction. Now, again, in oxidation, what you will find is that compounds will gain oxygen. And once they gain oxygen, we consider that to be oxidation. Now, we said that we can link the concept of electrons. So under oxidation, in terms of electron, this is the loss of electrons. And so when a substance or element or compound loses electrons, then technically we know that we are having oxidation taking place. And then as a student, you will make the link because you would have learned that in terms of elements, metals are the ones that lose electron. So metals are the ones that are being oxidized. So they lose electrons. Now, just like redox, just like reduction, rather, when you have oxidation, you also have an implication for the oxidation state. And so oxidation is an increase, in the oxidation state. And as I said before, once we have completed this, we would have dived into what exactly is the oxidation state. So now we have this concept of both. And if you really look at the two concept, reduction, oxidation, you would have noted that they're basically opposite. And so if you can remember one as a student, you should be able to know the other. So if you know what reduction is, automatically you should know what oxidation is, because oxidation is the opposite of reduction. So in Jamaican terms, persons like to make things a little bit easy. And so we have a jargon. We call it oil rig. And a lot of students will know this. But if you don't know, the oil is saying oxidation is loss of electron. Let me put that beside it. Now, the only disadvantage of oil rig is the fact that it's really just focusing on the electrons, in the sense that if you're asked about the oxidation state, some persons may not understand what is happening. Is the oxidation state increasing or decreasing? Because oil rig focuses on the electron. And so the rig is reduction is gain of electron. So as a student, if you can remember that jargon, then you should be good in terms of knowing what happens to a compound if it is being oxidized or if it is being reduced. And so this is the foundation of oxidation and reduction. So we're going to take it now and deal with, I just allow that to sink in. If you have any questions regarding what we just go through, you can always ask. You are now going to be zeroing in on the oxidation number. This is what is critical. And so can want to eliminate this. And normally for my students, I always mention that there's a difference between when you're talking about the ion and when you're talking about the oxidation number. And I'm going to use magnesium as an example. So we know magnesium, again, has the atomic number 12. And so when you work it out, we know that it would have had 2 electrons on the outer shell. Since it has 2 electrons on the outer shell, those electrons are what causes magnesium to be unstable. So a little background. As a student, you should be knowing this info. So what magnesium will do to become stable, it will lose those 2 electrons. And that's where we have a 2 plus, because magnesium atom has the same number of protons and electrons. And I soon get to why I'm mentioning this. So when you think about the 2 plus charge, that is the charge of the ion. So we know magnesium is a cation. And so we said 2 plus for the ion, the ion, the ion, the ion. And so even sometimes as teachers, we make the mistake or we say, you know, magnesium plus 2, and we are talking about the ion. But it shouldn't be done like that. So when you look at the ions, we should be speaking about the charge and then, well, the number, the magnitude, and then the charge. So 2 plus. So when you look at the charge, you would have seen that the number is in front of it for the ion. Oxidation state. It's basically the same thing for the ion. So I tell students, if you're familiar with the ions, then you should be able to work out the oxidation state. So this is, there are rules that we use to assign the oxidation number. And this is one of the first rules you can get to or get to understand. So if magnesium is a 2 plus, then the oxidation state of magnesium, it's really plus 2. So the oxidation state is the state that the atom or the ion is in. So please make this connection. Even with you knowing the atomic number, and again, CXC says you should know the first 20 atomic numbers. If you can get to the group, then you know the charge of the ion, whether a cation or an anion. And if you can get to the ion, then you will know the oxidation state. So all ions, their oxidation state is a representation of the charge of the ion. So if I have aluminum ion, an aluminum ion, again, aluminum has 3 electrons on its outer shell. So it is technically 13 electrons. So aluminum, in order to become stable, because this is where all of it is coming from, it will basically lose those 3 electrons. And so it become the ion is aluminum 3 plus. And so from you see that as a student now learning about oxidation and reduction, you should make the connection to say that the oxidation state of the aluminum is a plus 3. And so that is it, that is how it is for the ions. Once you know the ion, you should know the charge. So let's even use, you have some elements that their oxidation number tends to change. And that's why we have rules in assigning the oxidation number, which we're going to go into. But while we go into those rules, the first thing as a student, the rule is that you should be able to relate to the charge of the ion is a representation of the oxidation number. So all you're doing is writing the charge first. And so we're going to now venture into some of the other rules. How do we assign oxidation number? Because not all of it's not going to be that straightforward for every compound. or every ion or every element. So the first, and I'm saying this under my perspective, the other simple rule: if the element is by itself, so it's not bonded to any other element, then the oxidation number is going to be zero. So say for example, if you're doing any form of reaction and writing balanced chemical equation, what if they say aluminum is reacting with chlorine? Aluminum, which is technically a metal, is just a solid at room temperature. I'm just putting in this. We're reacting it with chlorine. We know that chlorine is one of the 7 diatomic elements. So we have to have that subscript of 2. We say when this reacts, uh, normally I use the arrow, but for simplicity and monitoring, I use the equal sign. So guys, remember those equal signs that you're seeing on your screen is really representing the reaction arrow. So we would have obtained, and again, if you are a student who don't know how this happens, then you have to go back to writing chemical equation, or writing chemical formulas rather. So aluminum chloride will form. And aluminum chloride has this formula. Now, the thing about this equation, here is how you're going to have to learn to apply. Now, sometimes they will ask you in CXC, who is being oxidized, who is being reduced. And I'm just using this simple equation to kind of show you how you can utilize. So normally, we said that scientists used to use oxygen. Now again, if you look at this equation, typical example, there's no oxygen in this. So you're not able to say, oh, aluminum is losing oxygen, the chlorine is gaining oxygen. So you're not able to tell based on the concept of the oxygen. So there are 2 other ways you can look at it. You can look at the loss, or you can look at in terms of electrons, or you can look at it in terms of the oxidation state. So in terms of electrons, it should be easy in the sense that what really happens, we know that aluminum, and for the purposes of this, let me just balance this equation. So, because I don't want it to be that persons are asking how we have 2 chlorine and 3 on that side. So we find the lowest common multiple of the 3 and the 2 for the chlorine. And so that would be 6. So if I want to get 6 chlorine on this side, I put a 2 there, right? If I want to have 6 chlorine on this side, I put a 3 there. Now when I place the coefficient here, it also affects the aluminum. So I have to have this. So persons were wondering if so this is the balanced chemical equation. And usually once you're doing an equation in chemistry, you should really be working with a balanced equation. For the concept of this topic, maybe going forward, I may not be balancing the chemical equation, just to zero in on the concept of the oxidation state to get you to understand how you can apply to know who is being oxidized and reduced. But please remember, once you're writing any equation, it should be balanced. Now, when we write, we know that this is saying we have 2 atoms of aluminum. Going back to what we initially said, if the element is not bonded to another element, then we would know that the oxidation number is 0. And this is the reason why. In this concept, there isn't any charge because the same number, and I have given a test to several students, and I recognize that students are making this misconception. Persons are thinking that the atomic number is the number of protons and electrons. I'm not sure why we're getting that. I'm not sure why we're saying that, but that is incorrect. The atomic number is a reflection of the protons only. Now, I can think of why the misconception comes in, because as teachers, sometimes we say, and it's not incorrect, but you just need to remember, when you have an atom, you have equal numbers of protons and electrons. So let's go again. So technically, the atomic number is a representation of also the number of electrons in an atom, because electrons will change. So prime example, and I have to speak a little bit about it, even though I go off the topic, it is something that I say repeated. So say for example, magnesium ion. This cannot have the same number of protons and electrons because this ion would have lost electrons. And so if your definition is it is the number of protons and electrons for atomic number, these are not the same in an ion. So you have to be careful. The proton does not change. And so when speaking about the atomic number, you will say it is a representation of the number of protons in an element or in an atom. We use the link in the sense that if you have the atomic number for an atom and the zero, going back to it now, making the link, why aluminum will have a zero is because each electron is being cancelled out by each proton. So there isn't any charge. This aluminum is neutral. There is no positive or negative charge. So the aluminum will have an oxidation number, or the oxidation state of the aluminum is zero. Any element by itself has an oxidation number of zero. Once you get that, life becomes easier. So that's one rule. So I reiterate the other rule. We said that in case of the ions, the magnitude of the ion is a representation of the charge for the oxidation number of that ion. So we know that we have 7 diatomic elements. 7, diatomic elements. We have one in our possession in this equation right now. And so they too have that concept of being zero. So even though, and if you can recall what I said, if they're not bonded to any other element. So while you have 2 chlorine atoms here bonded together, they are of the same element. And so the concept is the chlorine also has an oxidation state of zero. Now, when we look at the aluminum chloride, as a student, remember aluminum, what would have happened when you look at bonding? Because aluminum chloride is considered to be an ionic compound. And I really want to get something off of the little chest right now in terms of that as well. And I've been seeing it happening in the classes. Students, when we ask them, what type of compound is this? They're not able to respond. So let me clear it up right now. You see, once you see a metal, it can't be one covalent compound because technically a covalent compound is one where you have two nonmetal. So please just use this. The moment you're seeing a metal, automatically you should be thinking ionic compound. Why? Because again, a covalent compound would not have a metal in it. You would actually have two nonmetals. Now, the problem may comes in if you're a student and you basically just don't know what's a metal from a nonmetal. So if I say sodium chloride, if you don't know that sodium is a metal, then you're back at square one with a problem. But all students should know the first 20. And so outside of the 20, you may have like zinc and copper, lead, iron. These are the elements coming up, silver, gold, but they don't come up a lot. So at the end of the day, if you get a compound when you're doing bonding, and again, sorry for the stray, but I just want to clarify this because I'm tired of seeing the misconception our students hesitant in telling me what is an ionic compound. Guys, if you look, remember, the ion, the cation is always written first. So when you look at the first element in the compound and it is a metal, please just know that you're dealing with an ionic compound. So your duty as a student doing CSEC chemistry, if you have not done so, please learn the first 20 elements. It will make your chemistry life much easier. Please learn the first 20 elements in terms of their atomic number. So let's get back why I'm mentioning all of this. Remember, when you're doing the bonding, covalent bonding involves the sharing of electron. Now, this is ionic bonding. So what is going to happen is that, again, right away, we just learned this, so we could have made reference to it. We know that oxidation is the loss of electron, right? And so aluminum, we spoke about this. Metals lose electron. So automatically as a student, if you're asked this question, you can use that to make this link. But you have equations that are more technical. But a simple equation like this, it is really straightforward. Aluminum must be oxidized because aluminum is the one that is losing the electron. When you go back to and that's why we learn these topics as in the particular order. So you would not have learned oxidation and reduction before you learn bonding because it would have been a challenge. So take your bonding knowledge right now. Aluminum is the metal. It would have lost those 3 electrons to each chlorine. So what you find is that chlorine is gaining the electron. And of course, the gain of electron is reduction. So the chlorine is being reduced and the aluminum is being oxidized. But as I said before, some equations that we're going to be getting into are a little bit more technical. You can't just look at it. This is very simple because we have a metal and a non-metal reacting. And so it's very straightforward. We know that metals undergo oxidation because metals lose electron. We know non-metals, one sec, So we know that the thing is, if we can track the electrons as well, or the oxidation state rather, then you can tell who is being oxidized and reduced. So this is, we dealt with it in terms of loss and gain of electron. Let's look at it in terms of oxidation number. So we know aluminum is basically 3 plus. And so this compound right here, so is an ionic compound, so it's made up of ions. And we said that if it is that we have the ion, then the oxidation number is a representation of that ion. So right now the aluminum is a plus 3. Next point I want to talk about when we're going to be doing this chlorine. You see the chlorine, even though we have 3 of them, when you're talking about the oxidation state, you're talking about the state of one atom or one ion of that element. So sometimes students will see this and say, sir, the oxidation state would have been a -3. No, the -3 is for all of the chlorine ions. So when you're referring to the oxidation state, please remember you're looking at it in terms of one of those ion or atom. So one chlorine ion would have been, and I can go back to this. So we know each chlorine would have been a Cl minus. Technically, there's a 1 there, but we don't write it. So it's a 1 minus, right? So the oxidation state would have been a -1. And so now we have assigned oxidation numbers to the different elements or compounds in this reaction. Remember we said reduction is a decrease in oxidation number. So we're looking at it. Chlorine is at 0. And this is another problem that I'm having when we touch this topic. Our number line. When we were toddlers, primary school, we got the number line and we mastered it. And so we come here and we act as if we don't know how to do the number line concept. So if I'm moving from 0 to -1, it means that I am decreasing, right? And so as we said before, reduction is a decrease in oxidation number. So even if you never know the aspect about who is losing electron, who is gaining electron, this is another way. And I'm telling you, this is really one of the most effective way, because the equations that you're going to be getting are not going to be as simple. You might get these, you might get this for a multiple choice, you even might get it for a paper too. But you need to learn the concept of assigning oxidation number basically using the rules. So we're using the rules. So the rules that we've gone through so far. 1, the ion. So the oxidation state of an ion is the same as the charge of the ion. So that's why when we look at this, all we do is just flip it around. Aluminum is a 3 plus, oxidation state plus 3. Chlorine or the chloride, 1 minus. We're not saying that, so we don't normally say 1 minus. We normally say minus. But remember, there's a 1 there. and so the oxidation state is a -1. So when you look at this, going again, 0 to -1, we say that the oxidation state of the chlorine is decreasing, and so the chlorine is being reduced. When we look at the aluminum is moving from 0, and usually the plus is what that don't give the problem. Is the negative and the 0 is the one that students may fall off on. But as I said before, go back and read the number line and understand the whole place value. So 0 to +3, I'm increasing. And we know an increase in oxidation state is oxidation. Now, I am doing oxidation and reduction, and so I recognize that I can input certain information at different points that will make it more beneficial. So you see right here, I'm going to talk a little bit about these two. We have what we call oxidizing agent, and we have what we call a reducing agent. And it's very simple, and not because I'm the teacher, but if you really think about it. So the oxidizing agent is the agent that is causing oxidation to occur. So technically, who is being reduced? Who is being oxidized? So let's go again. Who is being, or who is the one causing an element to lose electron, or who is the one causing another substance to gain electron? So that's really what the oxidizing and the reducing agents are. So who in this is causing the other element or compound to lose an electron? So technically, the chlorine is the one, Mr. Chlorine is the one that is causing the aluminum to lose electron. And so Mr. Chlorine is the oxidizing agent. So here's the thing. What was happening to Mr. Chlorine? Mr. Chlorine was being reduced. So here's the link. The compound or the element that is being reduced is the oxidizing agent. So again, the compound or element that is being reduced, they are the ones that are the oxidizing agent. Likewise, who cause the element or the compound to gain electron? Who is doing that? Mr. Aluminum. If aluminum wasn't there, chlorine would not have any electrons to gain. So aluminum is the one that is causing chlorine to gain electrons. And so we look at what was happening to aluminum. Aluminum was being oxidized. And so the element that is being, or the element or the compound that is being oxidized is actually the reducing agent. So later on, we will look at some of the popular reducing agent, popular oxidizing agent that we actually use in the lab, and we can look at real life scenarios when you are drunk drivers operating a motor vehicle, they want to test how intoxicated the person is. It's the concept of oxidation and reduction that is used to determine if that person would have been sober enough to be driving. So later on we look at that. But just to put this in right here, so automatically, guys, if you know the element or the compound that is being reduced, you know the oxidizing agent. If you know the element or the compound that is being oxidized, you must know the reducing agent, because the element or compound that is being reduced is the one that is causing the next compound or element to be oxidized, and so it is referred to as the oxidizing agent. The element or compound that is being oxidized is the one causing the other compound to be reduced, and so it is the reducing agent. So we have done two rules, right, that will help us to assign oxidation number. Because once you can master this, once you can master assigning the oxidation number, any equation you get, you just need to fill out the oxidation number and track the electron, or track the oxidation. Is it the state that is going up or is it going down? And then you can determine who is reduced, who is oxidized, who is the oxidizing agent, who is the reducing agent. So let's look at two other rules. Mr. Oxygen always has an oxidation number of -2. So when oxygen is there in our compound, it has an oxidation number of -2, except, there's an exception, except when it is in a peroxide. And the only peroxide that we will basically have, your level that you will be using, is hydrogen peroxide for this compound. So oxygen, once it is not in a peroxide, any compound where you see it in anywhere you see the oxygen, just know the oxidation state is -2. Cool. The next one is Mr. Hydrogen. His oxidation state is always +1, unless Mr. Hydrogen is bonded to a metal. When it's with a metal,
Excuse me, sir. I'm going to join from another device.
it's a problem. So when bonded to a metal, it's going to have an oxidation number of -1, because you know that the metals, again, when you think about it, it is really about the electronegativity of the element. So who is more electronegative will get that negative charge when you're assigning the oxidation number. So these are two rules that govern. So basically we went through four of them. And these are the ones that will be helping you to assign oxidation number. We have two more that we're going to be going through. Now, when you have a neutral compound, and any compound, any compound that you're not seeing a charge. And so technically, when we are talking about a charge, we're talking about like those polyatomic ions. Polyatomic ions, they would have had a charge. So neutral compounds, when you add should be equal to 0. So when you add, and I'm going to give you a prime example. If we look at, let's go back to the compound that we were doing a while ago, that reaction. So here, so aluminum, we're not talking about the coefficient that is placed in front of it to balance now. We're just ignoring this. So when we're looking at oxidation, we're ignoring that too. So we're just focusing on this part of it. So this is considered to be a neutral compound. Why is it a neutral compound? When you look at the charge, well, when you look at the compound, you're not seeing any charge. Because from day one, when you visited the whole bonding, when you look at the ionic bonding, you would have recognized that technically the aluminum is bonded to 3 chlorine ions or atoms, causing them, to gain the electron. So the thing is, even though let's make this distinction now. So this is why sometimes it creates a problem for students. Even though I told you that when you're looking at the oxidation number, right? When you're looking at the oxidation number, you're looking at one of the ions or one of the atom. So that's why we have a -1 here. But if we're talking about the overall compound now, we have to take into consideration, that's what we're talking about when we add the overall oxidation charges. It should equal to 0. So we recognize something we should know. If we're not seeing a subscript, we know that it is 1 aluminum. So 1 times a +3 is a +3. Now, the oxidation state, all you're doing is multiplying that by the amount of atoms that you have. -1, because each of the chlorine is -1, and you have 3 of them. The oxidation state in total would be a -3. And so +3 and -3 equal to 0. So that's what we're saying. And you're going to be seeing how we can use this to work out. Because as I said before, not all elements, the oxidation number is straightforward. They have some elements. Mr. Carbon is one of them. Sulfur is another one. Nitrogen is another one. Those 3 elements, they tend to change their oxidation state. So it's not a saying that carbon is always this. So nitrogen is always that. You have to work it out at some point. Sulfur is always that. So they technically change their oxidation number. And so that's where this rule comes in, right? So the oxidation, overall oxidation state of a neutral compound. So one where you're not seeing any charge at the top should add up and give you 0. So again, when we look back, what we did to get this, how many atoms of aluminum? 1. My bad, 1. And the oxidation state is a +3. So 1 times a +3, overall, it is a +3. How many atoms of chlorine? 3. Each of them has an oxidation number of -1. Because I told you initially, this -1 is a reflection of 1 atom. So since we have 3 of them, then it must be 1, -1 times the 3, which gives you -3. And so we end up with 0. And we soon get to some working out. A matter of fact, I would have to do the working out to show you why that rule is important. And so I'm going to write 2 compounds. You remember that little thing I talk about in terms of persons when I ask student, is a compound ionic or covalent? So right away, you should know that this is a covalent. Most students will know because carbon dioxide is a popular compound that we use. We use it and exhaust it. But if you look at the first element and you're seeing a nonmetal, technically, you're heading down the covalent road because if a metal was present, it would have been written first. So I'm just giving you a little insight as how to can quickly deduce if a compound is covalent or ionic. So you see a compound, you look at the first element, oh, I'm not seeing a metal, then automatically you should start to think that, this compound might be a covalent. The thing is, as I said before, the problem comes in when students are not able to identify which compound is a metal or a non-metal. So if I say sodium, calcium, magnesium, barium, whichever way you want to pronounce it, lithium, carbon, oxygen, nitrogen, sulfur, phosphorus, if you're not able to categorize those as either non-metal or metal, then you're going to have a problem because that will not help you because you still don't know who is a metal or non-metal to use that little trick or that little ease of determining. I'm going to write another compound as well just to show you how we can apply the rules that we just discussed. Now, again, usually because we understand that it is set in some estimation, it is set for oxygen. So majority of the time we have either applying 2 or 1 rule that will use to assist us in getting to the oxidation state of a element in our compound. So those 2 carbons are underlined. We have carbon dioxide and we have carbon monoxide. As a student, you should also know how we get to those names. If you don't, get back to naming covalent compounds. Now, the thing is, while you have carbon in both these, each carbon, I can tell you, in these separate compounds have different oxidation number. And I'm going to show you why. Now, this comes with a little part of math. And again, once you start to do math, people start to, draw away, start get fidgety. We start get, boy, I can't bother with it. But it's simple math. We're not going into any Pythagoras theorem. I always say this. We're not doing any bearings and any cosine rule. All we're doing is multiplying, dividing, subtracting, doing maybe a little transposing. But in this case, we have to do a little algebra. So the compound, we look at it and look at the rules that we can apply. The first rule we can apply is the one about oxygen. We know that oxygen always has a oxidation state of -2. And so guys, for this topic, if you want to master the topic of oxidation and reduction, you have to master the rules. Know which rules to utilize to get, because if you can get to the oxidation state, you can use it to determine who is oxidized, who is reduced, who is the reducing agent, who is the oxidizing agent. So watch me now. We're going to call the element that we want to know X. So We mentioned one rule. Oxidation state of oxygen is always -1. So we also know when we look at carbon dioxide, it's a neutral compound. So whatever the oxidation state of carbon is, when you add it to the oxygen, it should equal to 0. So let's put that in. So X, which is the oxidation state of the carbon, plus we know that we have 2 oxygen, right? And each oxygen is a -2. When we combine that, we should get 0. So we get an algebra. I'm not too want to call the word, because once we mention anything about math, people start get fidgety and start, me can't bother with the calculation. 2 times a negative, well, a positive, well, 2, which is a positive, times a negative. I'm just going to work it out like a math problem. We get -4 equals 0. Now, again, this creates a problem when we lack some basic mathematical skills. And I'm not bashing anybody, but you have to learn these little things because we see where they cross. So even though we are doing chemistry, you still have to know some level of numeracy. So the rule is, if we have the 2 sign, we keep the sign of the negative, which is equal to 0. Now, initially when I started doing math, I recognized that I had a problem with how they spoke about this, but I'm going to deal with it. Now, if you want to get x by itself, to get rid of that -4, and I'm going to just talk like math, I would have to add 4. And the rule is, whatever you do on one side of an equation, you have to do it to the other. So also, you're going to have to add 4 over here. So the -4 and the plus 4, leave x over this side. 0 plus 4, we have a plus 4. Because we are talking in terms of oxidation number. So let's go back and revisit now. And this is what you can do to check your answer. Remember, we said that the oxygen is a -2. So when you look at that, and if we're using 1 would have been -2, right? Because we're looking at 1 oxygen. And then 1 carbon is a plus 4. So if you're zeroing in, if you're zeroing in on the concept of what is the oxidation number, this is what it will be looking like. So the carbon is actually a plus 4 and the oxygen is actually a -2, right? Now, the other concept students will ask is that, but sir, remember you tell us that when we work in that the overall adding of the oxidation numbers should equal to 0. And if you do the overall adding, yes, because when you're doing the overall adding, you have to take into consideration that you have 2 oxygens. So it's 2 times the -2, which is a -4, plus 4 plus -4 equal to 0. So you get back to the whole concept that we mentioned earlier. When you have a neutral compound, the oxidation state of all the atoms. So I want to make that distinction. When you're doing the questions, the oxidation state that you're going to mention for an element is going to be of one. One dege one of the atom in that formula. So the one that we're focusing on is going to be -2. But if we're doing the rule, if we're talking about the rule of adding all the oxidation number, then we have to take in account how much atom is there. So that's why I would have multiplied that -2 by 2 to get -4. Add them, we get 0. So don't think that because this is the case, every time you see carbon, carbon is going to be A plus 4. So let's prove the point. We said that we have carbon monoxide to work out. So again, we're asked what is the oxidation number of the carbon in carbon monoxide. And again, we apply the rules. The rules are there to help you. If you can pick out which rule you're going to use, it's going to make it great. So we use the rule, we're seeing oxygen again. So we know oxygen is a -2. Once it's not bonded to or once it's not in a compound, a peroxide. Yeah? We also say that when we add the oxidation number of the atoms, the total atoms in the compound, we must get 0 if this compound is a neutral compound. And carbon monoxide is a neutral compound because we are not seeing any charge. So right away, if you have a math brain, you can look upon this and know, say that's the oxidation number for carbon. But let's work it out for the benefit, because it's not always this simple. But if it is, you can look at it. So again, we call the one that we want to find out X. We said that when we add it, when we add it to the other oxidation number, which is -2 in this case, we should get 0. Again, the mathematical principle is that when we have those two unlike signs, we keep the sign of the negative, right? We say that is equal to 0. Students are going to come and say, sir, we always go this long route, and what we can do say this, move the 2 over that side and all of that. If you're okay and you're fine in terms of the mathematical principle, please just be fair and do it. But if you're somebody who does it and then you realize that you're running into problems, then I suggest you work with concept. If I want to get X by itself, I have to add 2. If I add 2 to one side of my equation, I need to add 2 to the other side. The -2 plus 2 cancels out that 2, and so the 0 plus 2 leaves a +2. And in this case, please note that Mr. Carbon actually now has a oxidation number of +2, while oxygen has an oxidation number of -2. And again, in this case, we have elements, we only have one of each element. So automatically, both of them, when you add them, they equal to 0. So I'm just using this part as an example to explain to you carbon, sulfur, nitrogen, those three elements are like that. They change their oxidation number. The iron, the copper, those elements may have a difference in their oxidation number. So you can't take it for gospel that carbon is always +2. You can't take it for gospel that carbon is always +4. So when you get those elements in the compound, in the chemical equation, because carbon dioxide could be when you do like a acids and base reaction, acid and metal carbonate plus an acid gives you a salt and carbon dioxide and water. So writing that equation, carbon dioxide is being present, so you might have to work out the oxidation number of that element, right, to determine who is being oxidized and who is being reduced. So finally, one of the other rules that we can apply is the rule about polyatomic ion. I'm going to use the nitrate ion for this example. So the nitrate ion has a negative charge. Say for example, I need to know, as I said before, nitrogen is one of those elements. So like this, I wouldn't know for nitrogen. But the rule is, whenever you have a polyatomic ion, the oxidation numbers, when you add them, no longer equal to 0, but it is equal to the charge of the ion. So again, when you have a ion, a compound that is not neutral, so a polyatomic ion, like what we have here, the nitrate ion, when you add the oxidation number of the atoms in that compound, it no longer equals to 0, but it is equal to the charge on the ion. So when I add up the nitrogen, when I add up the oxygen, it shouldn't be equal to 0. It's going to be equal to -1. And again, why is that the case? Because that's the rule, whatever charge it is. So let's look at sulfate. I know I haven't worked it out yet. I'm going to show you in a second. But just to explain a little bit further about what I'm talking about. When you add the oxidation number of the sulfur and the oxygen in this case, you should not be equaling it to 0. It's now going to be equal to -2 because that is the charge on the ion. So let's dive right into an example and work it out. So we have these two that we're going to be doing. What if, you get an equation and nitrate is in there? Or they can just give you, I've seen questions where they just give you the compound and says, deduce the oxidation state of the nitrogen in this polyatomic ion. What do? We know the rules. One of the rules is oxygen is always -2 unless it is bonded to, or unless it is in a peroxide. We're not seeing it in a peroxide, so we know it's a -2. The next thing is that when we add, because of all of that, when we add, we're going to be equal to the charge on the ion, which is -1. So what do? We create that expression. We call nitrogen X because we don't know it. X plus, we have 3 of the oxygen, right? And then we said that it's going to be equal to -1. this is what you have. So right here, we have, and I may go the long route, but again, I like to go the long route not to make a mistake or to show persons in its entirety. So the plus, the 3 times the negative 2 would have given us a negative 6. So again, some persons may have a math brain and automatically them go on and get the answer already. Them work out the answer already. But if you're not that type of person, I suggest you continue or until you get it, you work it like that. We know that that is a negative 6, which is equal to negative 1. We said that we want to get x by itself. Let me just carry down this. We want to get x by itself. And so we said that we have a negative 6. So we're going to add 6. And if we add 6 to one side, we also have to add 6 to the other side. And so right here we get x being equal to plus 5. And if we go back, applying that rule, we know the nitrogen is a plus 5. We know that the oxygen is a negative 2, right? As we said, if we were working with the rule, would have been 2 minus 2 times the concept that we have 3 oxygen, which is negative 6. And so plus 5 plus negative 6 equal to negative 1. I'm hoping that you can see. So even for you as a student, when you're in the exam and you've gotten the answer, you can double check by plugging it now into the overall compound to see if it works and give you, whether if it was a neutral compound and it gives you 0 or whatever. And so you can be assigning the oxidation number. Bear in mind, you being able to assign the oxidation number, guys, is a prerequisite, because these are the things, these very same compound. So you might have potassium nitrate, you might have sodium sulfate in compounds. And so you would have to know that when you work out the charge, it will help you. So if you're asked to deal with the sulfur in this compound, it's the same concept. So we know that sulfur is considered to be the X plus. We are having a situation where we know for oxygen, each oxygen is negative 2. This will not be equal to negative 1. This will not be equal to 0. It will be equal to the charge on the ion, which is negative 2. So when you have negative 2, just work it. Plus, we get a negative 8, which is equal to negative 2. Two like charges, just join in, two like charges, negative, equal to negative 2. We want to get x by itself, so we say x minus 8 plus 8, and of course, if we're whatever we do to one side, we have to do to the other. So we have to plus 8 on this side, which leaves us x equal positive 6. And if we check it, let's go back. So we know the sulfur is a positive 6. We know each oxygen is a negative 2. We have 4 of them. So technically it's a -8, and as we said before, if you really want to backtrack, the +6 plus a -8 equal to -2. So we have copper oxide plus ammonia. We know ammonia is a gas. As I said before, just with the ease of working in the Word document, I could put the arrow, but sometimes the arrow, when we're moving and putting in values, it creates a little problem. So where you see those three equal signs, that's where your reaction arrow will be. All right. We're going to be getting copper solid and also nitrogen gas. And of course, water. Mm, H2O. Like I said, for this concept, I will not necessarily use or go into the whole balancing chemical equation because I really want to just focus on, you know, the concept of oxidation and reduction. So you can balance this when you get the opportunity. But what if the question asks you, who is being oxidized, who is being reduced, who is the oxidizing agent? So these are the questions. I said, boy, sir, I'm gonna think I can do this. But I gave you all the knowledge. We've discussed all the knowledge that would be necessary to figure this out. And so let me show you. If we want to know who is oxidized, and let me bring this down a little bit. If we want to know who is oxidized or who is reduced, then there's a we can you remember earlier on, if you weren't here, you look at oxidation and reduction in two ways. Well, in three ways. Oxidation is the gain of oxygen. Oxidation is the loss of oxidation, sorry, is the loss of electron, or oxidation is an increase in oxidation state, increase in the oxidation number. We also look at reduction. We said reduction, right? When something is reduced, who can remind me what is happening in terms of oxygen? What is happening? So the fact that the copper is losing oxygen, we're just assuming. We're working with it, so we're going to double check. But the best way to do is to assign oxidation numbers straight across the board. We have some elements that we can work with by assigning the oxidation number easy. We said that copper, what would be the oxidation number for the copper? Copper is by itself in a bond to nobody. And once that is happening, we know that the oxidation number is 0. Let's work it out. Nitrogen, even though it's 2 atoms of nitrogen, we know that nitrogen is diatomic, and so it's still not bonded to any other element, so the nitrogen is 0. Those are the first, I would say, the simple ones that we can relate to. Let's relate to some other simple ones. Look at this right here, so jump back to the copper oxide. We know oxygen in this is equal to -2. Let's jump back to one where we also know. We know that the hydrogen right here is -1. We know that the hydrogen here is -1. We know that the oxygen here, sorry, is negative, sorry, not -1. Give my bad. Hydrogen is always +1, and I'm going to correct me. So this is +1. We know that oxygen is -2. So those are the ones we work out. We still have copper to deal with. So copper, if we didn't know what is copper, we could have worked it out. But we have the rule in terms of copper to oxide. So we know that one, when we add the oxidation number, and we don't have to calculate it. But if you want to calculate it, fine. But we know that when we add them, since that copper oxide is a neutral compound, it should add and equal to 0. So that means that the copper must be a +2. Alright. So we've assigned oxidation number to everybody except nitrogen. Now, the oxidation number of the nitrogen right here, so if each, again, in this compound, we call this the ammonia, if each hydrogen is a +1, then when you add, you get a 3 plus. So if the rule is all the oxidation number of all the atoms would add up to 0, then technically the nitrogen must be a -3. If you don't know how we get the -3, you can work it out, right? So we know what us call nitrogen X, and as we said, X plus the oxidation number of the hydrogen would equal to 0, and you work it out. So see there, this is equal to 0. So what we do now is to track the movement in terms of oxidation state, oxidation number. We said that if we can do this, we would be good. Now if you notice, hydrogen is a +1 here. Hydrogen is also a +1 over here. The oxidation number is not changing. So we know that's not involved. The oxygen is a -2. Oxygen is a -2. Not involved. So we're going to be tracking the oxidation number of the copper and the nitrogen. So if you follow me keenly, so the copper Copper is moving from 2 plus and it's becoming 0. What is happening to the oxidation number?
It's reducing.
So it's decreasing. So we know that we did say it because we said that the loss of oxygen is actually reduction, but it confirms it now. Plus 2 to 0, we know that we're having reduction, right? So the copper oxide is actually being reduced. Track the nitrogen. And like I said, I hope you're seeing how beneficial all of what you learn, you're putting into play now. You can use it at your advantage, no matter what kind of equation them give you. Once you can work it out and assign oxidation number, you're good. See there? Nitrogen is leaving from -3 to 0. So what is happening here? Oxidation. Because we are having a increase in oxidation number. And again, if you're having a problem, remember it's number line. So you're at -3 and you're moving towards 0. So that must be an increase. So we know that the ammonia is being oxidized. And so, straightforward. If I'm being oxidized, who caused me to be oxidized? Which compound did cause me to cause my nitrogen to lose electron?
The hydrogen,
No. So the
the
other
copper,
compound. So we did establish that if a compound is being oxidized, the other compound is what is causing it to be oxidized. So it is the
copper
oxidizing.
oxide.
So the copper oxide is the oxidizing agent. It is what is causing the ammonia to be losing electron. And likewise, the ammonia is what is causing the copper oxide or the copper in the copper oxide to be gaining electron, which is they are the ones that are that is the one that is the reducing agent. And so once you can do this, again, your oxidation and reduction life has basically been completed halfway. The only thing that we would have wanted to capitalize on is to be able to be writing half equation, and we're going to be looking at some possible the oxidation common oxidizing agent, common reducing agent, and what it is that you're going to be looking for. So again, once you can assign oxidation number of any compound in the equation, you should be able to use that information to deduce who is being oxidized, who is being reduced, who is the oxidizing agent, who is the reducing agent. All right, so if we're supposed to do a recap, so when you look at just oxidation and reduction, we said that in earlier part I spoke about looking at it in terms of oxygen. We also can look at it in terms of hydrogen. So reduction is the loss of oxygen, reduction is the gain of hydrogen, right? Reduction is a decrease in oxidation number. Reduction is the gain of electrons. Once you do those, you can utilize it. Oxidation is the gain of oxygen. It's also the loss of hydrogen. It's an increase in oxidation number and it is the loss of electrons. So with those concepts, not all the time you will be able to be lucky to have oxygen and hydrogen. So the fact that the nitrogen is losing hydrogen, we know that that is oxidation. The fact that the copper oxide is basically losing oxygen, we know that that is reduction. But not all equations provide you with hydrogen and oxygen in them. So what you might have to do is to use the concept of assigning oxidation numbers. Remember the rules. If you have an element that is not bonded to another element, then the oxidation number is 0, just like in this case of copper and the nitrogen. We also should remember that hydrogen has an oxidation number of +1 unless it is bonded to a metal. We should also remember that, did I say oxygen or hydrogen? Well, oxygen is a -2 unless it is in a peroxide where it assumes a role of -1. In a compound where you have a neutral stance, when you add all the oxidation number of those elements or atoms, you should equal to 0. So prime example, the copper and the oxygen in this compound, when you add them, you get 0. If it's a polyatomic ion, when you add those ions, then you basically would be equal, when you add the oxidation number, it will be equal to the charge of the polyatomic ion. We said that if you have an ion, then the oxidation number is the same as the charge of the ion. And we did the example with magnesium. So magnesium is 2 plus as the ion, then the oxidation number is +2. So using these information, you can assign oxidation numbers. We say that if something is being oxidized, then it is acting as the reducing agent. And if it is being reduced, then it is acting as the oxidizing agent. So with that, I wish that this class was beneficial, opening your eyes in terms of oxidation and reduction, assigning oxidation numbers, talking about the rules, talking a little bit about reduction, a reducing agent, oxidizing agent. So we're going to be looking at in next class the reducing agents, popular reducing agent, popular oxidizing agents, and what is the outcome that we should be looking for, and also half equation so that we can move into electrolysis. Again, Mr. Thomas is the name. Like, subscribe, leave a comment, and keep on practicing.